Hello, in this video, we are going to talk about polar form, just trig form of complex numbers. So we're going to have rectangular form, which we'll talk about. Okay, so rectangular form is going to be a plus bi. So this is rectangular form. And then we're also going to talk about trig form, which I'll bring this up in a second. So this is a complex number. So that's 2 minus 3i, which represents that vector. Okay, and so the vector with that's 2 minus 3i, that complex number, starts at 0, 0, and ends at 2, negative 3. Now this is the imaginary axis instead of the y-axis. We have the real axis, and then we have the imaginary axis. And imaginary is for the complex numbers. So we have positive 2, negative 3. Now that is exactly the same. So this is rectangular form as the point 2, negative 3 on the complex number, or on the complex plane, excuse me. So it just is the vector that ends at that point. Now, trig form, I'm going to just write a new vector because it's easier. So if I have rectangular form, and let's say I choose the point 3 plus 4i. So that vector would be 3 and 4 on the I. So that's this vector. Okay, that's 3 plus 4i because it's the number 3 and then the number 4. In order to do trig form, which is polar form, we need to figure out r and theta. And then I'll show you how to write that in a second. So this is going to be theta. R is going to be, if that's 3 and that's 4, then this is definitely 5. So that's the radius. And theta would be found by making tangent theta is equal to y over x, or opposite over adjacent. So you end up getting about 53.1 for theta if you use inverse tangent here. So when you write trig polar form, you would write 5 cosine 53.1 plus I sine 53.1. This is polar form. Because if I multiply this out, I will get this. Okay, there's a shortcut for that, and we write it 5 cis 53.1. Now that's 5 is the radius, cosine I sine 53.1. So that's cosine 53.1 and I sine 53.1. The reason there's an I is because it's an imaginary number. Okay, now adding vectors, and we'll get to more of that later. It's just kind of like an introduction. If you added two imaginaries, if you added 4 plus I, so that's 4, 1, that's this vector. 1 plus 3i, so that's 1, 3, that's this vector. You would get 5 plus 4i, and if you remember, we were doing these before, this is the resultant vector if you were to add those. Okay, 5 plus 4i. All right, let's go ahead and go on to some problems. So here we go. And these are just really the ones that you should look out for. So we have rectangular form and we have trig form. This is a long version of trig form and this is a shortcut. I don't care which one you use. When you're writing the shortcut version, there really should be a little bit more space between the r, the cis, and the theta, but we'll talk about that. Rectangular form is a plus bi. The a and the b correlate to the x and the y. To find x, it's r cosine theta, and to find y, it's r sine theta. You already know how to find the radius. It's the same as every other problem we've ever done. Let's just use the Pythagorean theorem, and then tangent theta is y over x. You just need to pay attention to the quadrant. All right, so for example 2, they want you to express it in rectangular form. So your final answer is going to look like this. These are the easiest kind because you already know what r is. and you just distribute is really all that's happening. So when it's on the unit circle, I do want you to use the values that are on the unit circle. So we have 2, and then cosine of 300 is 1/2. Sine of 300 is actually negative radical 3 over 2. And if you were to distribute, so 2 times 1/2 is 1. And 2 times this is minus I radical 3. And that's it. So this is rectangular form. And this is trig form. So we're just changing formats. Okay. So try the next one. Push pause. And after you're finished, check your answer. Again, if it's on the unit circle, you cannot use decimals for this. All right, so for the next one, we have 10. This is again in trig form. Cosine of 135 is negative radical 2 over 2 plus I sine, so this is positive radical 2 over 2. And if you multiply this by 10, you're going to get negative 5, radical 2 plus 5I radical 2. And again, this is rectangular form. When you're writing an imaginary and a radical, it's always the number, the imaginary, and then the radical. That's the order in which you write them. All right, for example 3. So we're going to go ahead and change this. Instead of radian, we're going to go to degree mode. Same thing here. It's degree. I want everything to be in degree mode. So if you're going to convert from rectangular to trig form, you need r and you need theta. Okay, so you need 2 things. You need r and you need theta. If you have those 2 things, you're good to go. So here we go. So for the first problem, we need to sketch this picture. So again, you kind of look at this as negative radical 3 comma 1, because those are the coefficients here. This is like a 1. And when you look at the points, even though this is adding together in rectangular form, you're just looking at the coefficients. So if I were to graph this picture, because I need to find r and theta in order to do this. So if I graph this, we have negative radical 3, and then we have 1. And if you use the Pythagorean theorem here, we would get 3 radical 3 squared plus 1 squared equals r squared. So 4 equals r squared. So this is 2. So we have r is equal to 2. Now we need theta. In order to find theta, you should know that the answer is going to be somewhere between 90 and 180 because we are in quadrant 2. Okay, so we are in quadrant 2. So it's going to be over here. So when you do inverse tangent here, or tangent, tangent theta is equal to 1 over negative radical 3. You can simplify that if you want, or you can just put that directly in your calculator. So you would get tangent theta equals negative radical 3 over 3. If you remember the fraction one, that has to be, this will be 30, which makes this 150. So theta is 150. If you put this in your calculator and do inverse tangent, you're going to get theta is equal to negative 30. And negative 30 is in quadrant 4. We obviously know that our angle is not in quadrant 4, but 30 will give you the reference angle. And so that means that angle is 30, or you can just add 180 to that. Okay, so now that we have r and theta, then our answer will look like this. We use these 2 values to write our answer. So 2 times cosine 150 plus I sine 150. Or if you want to write the shortcut version, it would just be 2 cis 150, which means exactly the same thing. I don't care which method you use, but I just want you to know that they're interchangeable. Okay, so we're going backwards and putting it in this format. Okay, For this one, for the second one, we have negative 3i. So remember, it's always in a plus bi form. So we have basically 0 minus 3i. So my point is 0, negative 3 if I were to put that on an xy axis. So 0 for the x and negative 3 for the y. That point is right here. So if I wanted to know how long that was at 0, negative 3, then the length of that is 3. That's how long the radius is. If I wanted to know theta, then all you need to know is what the angle is at that point, which has to be 270. So your answer is just going to be 3 cis 270. Again, the long version of the trig form is 3 times cosine 270 plus I sine 270. And if you were to multiply that out like we did in the previous problems, you would get 3 times negative, or excuse me, you would get 3 times 0 plus I times negative 1, or negative I should say. And if you were to multiply this, you would get 0 plus negative 3i, which is negative 3i. So if you went backwards, you would get the same answer. And again, either one of these two answers is good enough. Go ahead and try the next two. And that's all we'll do for this video. So try the next two problems, pause the video, and then come check your answers. And again, just go ahead and do it in degree measure, not radian measures. We'll use degrees. So this point is 8, negative 8. Again, if you're just looking at the coefficients. So 8, negative 8, we're in quadrant 4. And this is going to be an isosceles triangle. So this is 8, and this is negative 8. Then I know for sure that that's a 45-degree angle, which means that this is 315. So I already know that theta is 315 degrees. Also, because it's a 45, 45, 90, if that's 8 and that's 8, then that has to be 8 radical 2, if you remember the formula for doing that. For 45, that's always radical 2 times the legs. If you did the Pythagorean theorem, you get 64 plus 64 equals r squared, 128 equals r squared. So the square root of 168 is 64 times 2. So that's 8 radical 2 for r. So your final answer here is 8 radical 2 cis 315. And again, you can write it the shortcut or the long way. It's always easier to use the shortcut. And again, it just means cosine. And then the second part is I sine for the 315. For the last one, if you have a plus, or the last one we're going to do in this case, so that's going to be negative 15 plus 0i, which is negative 15, 0. If you're graphing that, negative 15, 0 would be a point way over here. So that's a negative 15. So that would be r. R can't be negative, so the length of this point is negative 15, 0, but the length of that vector is 15. And then theta is 180 at that point. So your answer should be 15 cis 180. And that's it for the first 3 examples. I guess we skipped example 1. So, all right, continuing on section 8.2, we're going to convert between trig and rectangular form, but we're going to be using a calculator instead of the unit circle because these aren't going to fall directly on the unit circle. So make sure you have your calculator ready before you do this section. All right, so if it's in trig form, which this one is, we're going to change it to rectangular. And if it's in rectangular form, which this one is, we're going to have to change it back to trig form. So you need to know how to do each method. So going from trig to rectangular form is probably the simplest method because all you really have to do is distribute. So you're just going to multiply this times this. That's not on the unit circle. So you're just multiplying 6 times cosine of 115, and you're going to get negative 2.5. And then you're going to multiply 6 times sine of 115, and you're going to get a positive 5.4i. What you actually just finished doing is shown the actual location of that imaginary number, where that vector would be, or complex number, which is the same thing. So if you go to negative 2.4, so if I go negative 2.5, we're just going to guesstimate, and then 5.4, which is more than twice as tall. Then that vector should be, or should have, a length or a magnitude of 6, because this vector right here is negative 2.5 plus 5.4i. That's where it ends at that point. So if you were to use Pythagorean theorem on this, 2.5 squared plus 5.4 squared, it should equal 6 squared if you were doing this accurately. And then the 115, that's the degree from here to here. Okay, so the answer is this, but I just wanted you to know what you were actually figuring out. For the next part, when they give you the complex number in rectangular form, then we need to find r and theta so we can write it in trig form. Okay, so first, this is 5, negative 4. So let's figure out what quadrant we're in. So if we're at 5, negative 4, we're definitely in quadrant 4. So I know that this is going to be 300 and something, most likely. If you do Pythagorean theorem here, you're going to get 25 plus 16 equals r squared. So that's 41 equals r squared. So we get about, well, we're just going to leave that square root of 41. It's just easier. If you wanted to write that as a decimal, I guess you could. But let's just go ahead and leave it square root of 41. If that was a square root of 40, though, make sure that square root of 40 is 4 times 10. So that's 2 radical 10 that you would write. So r is square root of 41. If you use tangent to find theta, then tangent theta is equal to negative 4 over 5. If you put that in your calculator, you end up, for inverse tangent, you end up getting theta is negative 38.7. So that's 38.7. And if you subtract that from 360 to get to this point here, you get 321.3. So in shortcut for trig form, you get radical 41, cis 321.3. It's like this one right here would be 6 cis 115 degrees. This is the shortcut version of that. Same thing here. This is the shorthand version of writing it out with the parenthesis and multiplied out. Go ahead and try the next two. Check your answers, and then we'll be done with this section. All right. In this case, we're just multiplying. So we get negative 5.4. And then 6 times sine of 245. Don't forget the biggest thing that people forget when writing it in rectangular form is that there's no parentheses and there's no comma. So a lot of people want to write rectangular form as an ordered pair. It's not an ordered pair. It's a plus bi. It's a binomial, basically. So it's a whole number plus or minus an imaginary number. Okay, so just be careful when you write it in rectangular form that you don't put it in parentheses and put negative 5.4 comma 2.5i, because that's what we're used to doing. For the next one, we can write it as negative 7,2, so we can figure out what quadrant we're in. So negative 7,2, we're going to be in quadrant 2. So my degree angle will be 100 and something most likely. So we need to get r and we need theta. So in order to get r and theta, we do Pythagorean theorem. So 49 plus 4 equals r squared. So r is equal to square root of 53. And then for theta, theta is only going to give you a positive or a negative number when you do tangent. So it's either going to give you a positive number in this quadrant or a negative number in that quadrant. And if it's not in one of those two quadrants, then you need to add 180 to get to your answer. So this one's definitely going to give us an answer down here. It's going to give us a negative answer. And so then in order to find ours, we'll add 180 to it. Okay, so just remember that tangent is always, when you do inverse tangent, it's going to give you an answer here if it's positive, and an answer in this quadrant, excuse me, let me pick a different color, and an answer in this quadrant if it's negative. So this is going to be negative because we have a negative tangent. So let me do that over here so I'm not out of the way. So tangent theta equals 2 over negative 7. If you do inverse tangent there, you end up getting theta is equal to negative 15.9. So that's this angle here, 15.9. So if you add 180 to negative 15.9, you end up getting theta is equal to 164.1. Or the other way of looking at it, if that's your reference angle, then that's 15.9 right there. And since this is 180, then this has to be 164.1 degrees. All right, so final answer, square root of 53, cis 164.1 degrees. And that covers it for section 8.2. Go ahead and check the work. Later, I will be posting the work that goes with this section.